Okay, so we are continuing on with section 5.2, and we are looking at part 2, still studying the graphs of sine and cosine functions. But now we're going to be looking at how to graph horizontal and vertical shifts. So when there's a translation or translations happening to the parent function of sine or cosine. Okay, so we're going to be looking at graphing sine and cosine functions that are in this form. So if there is a horizontal or a vertical shift. Now remember, when there is a horizontal shift, if there's also a horizontal stretch, shrink, or reflection, you need to factor out whatever x is being multiplied by in order to see what the actual horizontal shift is. So like for sine, we would rewrite as a times sine. I'm going to change this to a bracket. Factoring out the b, that would be x plus c over b. And you can think about distributing the b back in, and we would be back to how that sine function is originally written. And then for cosine, same thing. A times cosine, factoring the b out, would be x plus c over b plus d. And the c over b is what the horizontal shift is. And then d is the vertical shift. Okay, and before you apply any horizontal or vertical shifts, you need to apply any transformation. So any vertical or horizontal stretch or shrink or reflections before you apply any horizontal or vertical shifts. Okay, so for graphing, this is my process for graphing shifted sinusoidal functions. Remember, sinusoidal functions refers to sine and cosine functions, functions that resemble sine. Now for the shifts, I do this slightly different from the book, or from how you have applied horizontal and vertical shifts in the past. You can apply them just by thinking about shifting each point of the transformed function or the parent function if there aren't any transformations. Or you can do it the way that I do. So following these steps, you want to, just like before, determine the amplitude and determine the period of the function by dividing 2 pi by whatever b is. And then we determine what the horizontal shift is by, remember, it's the opposite. So if you have like x plus 2, that means the horizontal shift is to the left 2 units. But if you have x minus 2, the horizontal shift is to the right 2 units. And that's why it's the opposite of c over b, referring to the horizontal shift. And then the vertical shift is d. So if the vertical shift is plus 5, that means the shift is up 5 units. And if it's minus 5, that would mean that the graph would be shifted down 5 units. And then I like to graph the function over one period that has been transformed, but not with the shifts, so that you get the shape of the sine or the cosine graph. And then if there is a horizontal or vertical or both shift, I move the x or the y axis. So if there's a horizontal shift, then you would be moving the y-axis in the opposite direction of the shift to show that the shift has happened. So like if there was a horizontal shift left 2, after you had graphed the non-shifted function, that just was vertically or horizontally stretched or compressed. Then you would shift the y-axis in the opposite direction. So I think I said left 2, so then you would shift the y-axis right 2 units, okay, to apply the shift. If there's a vertical shift, let's say up 5 units, then you're going to shift the x-axis down 5 units to apply the shift. You also have the option, and for the first example, I'll do it both ways, where after you, or as you go along graphing the points for the non-shifted function, you think about applying the shifts for each point. Either way works. It's your preference. Been successful, really successful teaching students with shifting the x and the y-axis, but again, your preference. So we're going to graph y equals to 3 times cosine of 2x minus pi. And I've given you the graph paper down here to graph. And I haven't given you the x-y axis because we're going to be, there's a shift happening. So we're going to draw this on our own. So identifying the amplitude, so the size of the waves is going to be 3. Okay, the period, to determine the period, I'm doing 2 pi divided by b, and b in this case is 2, so the period is pi. Now, because x is being multiplied by 2, in order to see the horizontal shift, the actual horizontal shift, we need to factor out the 2. The horizontal shift is not right pi units. So factoring out that 2, we're able to see that the actual horizontal shift is to the right pi over 2 units, right? Since that's x minus pi over 2, that's a horizontal shift to the right pi over 2 units. Which means if we're graphing shifting the axes instead of shifting each point, that means that the y-axis is going to go to the left pi over 2 units. So I still want to do the table just like we did in part 1. I'm doing the table in order to get the shape of the function. But the table is for the non-shifted graph. So my outputs, my y values, are for the graph of 3 times cosine of 2x, no horizontal shift. But I still take the period, divide it by 4 to figure out what I'm scaling my x-axis by. So I'll start at 0. Pi divided by 4 is pi over 4. So that means that my x-axis will be scaled by pi over 4. So 1 pi over 4, 2 pi over 4, 3 pi over 4, and pi. Okay, and this is cosine. The amplitude is 3. Cosine starts high. And there's no vertical reflection, so it starts at 3. We'll go down to 0, down to -3, back to 0, and end at 3. Okay, so since I'm going to be shifting the y-axis, I'm going to draw like a preliminary y-axis, the y-axis for the non-shifted graph. Okay, and I'm going to draw that in gray. You could draw it dashed, however you want, but that's not my final y-axis. The x-axis, because there's not a vertical shift, my x-axis will not be shifting. Also notice that no domain was stated, so just make sure that if no domain stated, you're at least graphing one period. If I can see one period, I'll probably extend it a little bit. But we're going to use the same scale for the x and the y-axis, even with the after the shift. So I'm going to have each notch here be 1 unit. Okay, so it goes up to 3. And then for my x-axis, I'm going to have every 2 boxes be pi over 4 units. Okay. So now I'm ready to graph the points that are in that table. So I have 0, 3, pi over 4, 0, pi over 2, negative 3, 3 pi over 4, 0, and then pi, comma 3. So that's 1 period. And then I'm going to extend the graph. You can either extend now, or you can extend after you have shifted. That is also your preference. I'm going to extend now. And I'll extend a little bit to the left. Okay, so I'm going to now shift my y-axis left pi over 2 units. So that would be over to here. And once we've done this, you could think of it almost like you graphed the non-shifted function and then like using the copy and paste for the graph, like you just moved it over to the right pi over 2 units. But instead of doing that, because that would be really difficult to do, you're actually just shifting the y-axis to the left pi over 2 units, and it has the same effect. And if you were given a domain, you just want to make sure that you have graphed over the domain that's being asked for. Not more, not less. Okay, so then the last thing that's left to do is to label, relabel. So 1, 2, 3, negative 1, negative 2, negative 3. And then same scale on the x-axis. So every 2 boxes is pi over 4 units. This would be pi over 2, 3 pi over 4, pi. If you want to keep going, 5 pi over 4, 3 pi over 2, 7 pi over 4, 2 pi, and so on. Okay, negative pi over 4. Make sure you're labeling, or make sure it's clear what your scale is for each axis. Right, there's my x-axis, there's my y-axis. Now the other way, and if you are happy with that method, you can skip through this next part. The other way that you could have done this is just thinking about shifting each point from the table, shifting each of those points to the right pi over 2 units. That also would have worked. So let me show you that. So for that, I'm not shifting my x and y axis, so I can go ahead and draw them and label. Okay, so I'm going to still have the same scale, pi over 4, pi over 2, 3 pi over 4, pi, and so on. Okay, so thinking about graphing each point. So from the table, we would have 0, 3, but it has to be shifted to the right pi over 2 units. So it would be at pi over 2, comma 3. Okay, then we would have the point pi over 4, comma 0. Shift that over to the right pi over 2 units, landing us at 3 pi over 4. pi over 2 comma negative 3 shifted to the right pi over 2 units lands us at pi comma negative 3. And then 3 pi over 4 comma 0 shifted to the right pi over 2 units would land us at 5 pi over 4 comma 0. And pi comma 3 shifted to the right pi over 2 units would land us at 3 pi over 2 comma 3. So then you can graph the 1 period, and you can follow the pattern and extend the graph as far as you need it to go. So when no domain is stated, it means over all real numbers. So that's why I meant like you just need to graph at least 1 period. So you can see if I were to move this graph over and line it up, right? They're the same graphs. Use the method that works for you for applying the shifts. Okay, so let's next look at when there is a vertical shift. Okay, color should we use this time? Let's use orange. Okay, first of all, this negative is a vertical reflection. The amplitude is 2, so the size of the waves is 2 units. The period is 2 pi divided by 4, right? I take b, and that simplifies to be pi over 2. So period is pi over 2. And then that plus 3 indicates that the graph has a vertical shift up 3 units, which means the y-axis will go down 3 units. Or if you're shifting each point, you're shifting each point up 3 units, your preference. Okay, so for making the table, to get the shape of the graph is just minus 2 sine of 4x, so no plus 3. Start at 0. When I divide pi over 2 by 4, that's the same thing as multiplying pi over 2 by 1/4. That means that my x-axis will be scaled by pi over 8. So 1 pi over 8, 2 pi over 8 is pi over 4, 3 pi over 8, and 4 pi over 8 is pi over 2. Okay, you can think about plugging these values into y equals to negative 2 sine of 4x, plugging those values in for x and simplifying. Or, you know this is sine. Sine starts at 0. Sine normally goes up then to its highest value, but because of that vertical reflection, it's going down to negative 2, back to 0, up to 2, and back to 0. Okay, it's always that same pattern. And we're going down first because of that vertical reflection. So because it's a vertical shift, I'm going to draw the x-axis in gray here first because that's going to be shifting. And I'll leave my x-axis, or I'm sorry, I'm drawing my x-axis in gray and then my y-axis in black because I'm shifting. Oh, I said I was shifting this was wrong. So sorry. I'm shifting the x-axis down 3 units. Sorry about that. Okay. I'm going to have every box for the y-axis be 1 unit. And then I'm going to have every 2 boxes be pi over 8 units for the x-axis. Okay. So graphing our points, 0, 0, pi over 8, negative 2, pi over 4, 0, 3 pi over 8, 2, pi over 2, 0. So that's for one period. Again, you have the option of extending the graph now, because this graph is being asked to graph over all real numbers. I'm okay with just the 1 period, but you might want to extend it. This time, just to do it a little bit differently, I'm going to shift my x-axis down 3 units. And then I need to label. So it's my x, y-axis. 1, 2, 3, 4, 5, 6. Negative 1, negative 2. Okay, and then I'm going by pi over 8. On the x-axis. And I'll extend it a little bit further. What's nice about doing it this way is that you're able to see the midline of the graph. Like where, so remember the midline when the graph is not shifted vertically is the x-axis. But if it has been shifted vertically, whatever that vertical shift is, y equals to that value will be the midline. Okay, so just extending a bit. And we'll do one last example where we have both a horizontal shifts are also known as phase shifts. That's more of a physics reference, but you should be familiar with the fact that a phase shift is a horizontal shift. We'll go purple. Okay, so I'm going to rewrite the equation so that I can see the horizontal shift because I can tell that there is a horizontal shift. So I'm factoring that 2 out. The amplitude is 3. The period is 2 pi divided by b, which is 2. So the period is pi. Horizontal shift left, pi over 2. Vertical shift down 2. That means to perform the horizontal shift, I'm going to move the y-axis right pi over 2. And I'm going to move the x-axis up 2 for the vertical shift. To get the shape of the graph, I make the table for the non-shifted version of the function, which is 3 sine of 2x. Dividing the period by 4, that means our x-axis is going to be scaled by pi over 4. Okay, so the table represents 1 full period of the non-shifted graph. Okay, this is sine. Sine starts at 0, goes up, back to 0, down, back to 0. So I'm going to draw both the X and the Y axis in gray because they're both shifting. It's kind of hard to see. I'm going to have the y-axis, each box represents 1 unit, and for the x-axis, I'm going to have every 2 boxes represent pi over 4 units. So I'm at 0, I go up to 3, down to 0, down to -3, back up to 0. So that's 1 period. You could extend before you perform the shift with moving the axes, or you could extend before. I'm going to move the axes now. So I'm going to move the y-axis to the right, pi over 2 units. That didn't go straight. And the x-axis is going up 2 units. Slightly off, but that's okay. And then I can extend. It's just a little bit harder, I think. It's nice to have that midline there still, but it's a little bit harder, I think, to follow the pattern. Not that much harder, but. And remember, you always have the option of thinking about the points from the table and performing the shifts for each point as you go. So you could have performed the horizontal and vertical shift, like the actual horizontal and vertical shift, gone left pi over 2 units, down 2 for each point in the period, and that would have worked just fine. Okay, and then do not forget to label your X and your Y axis. Okay, so pi over 4, pi over 2, 3 pi over 4, pi. And I just keep going. I just don't like my graphs to be super crunched together. Like I could have done each box as pi over 4 units. I could have done every 4 boxes as pi over 4 units. The way that you label is super important here. Okay, so those are vertical shifts and horizontal.